Good afternoon, everyone. Dear authors and invited guests, welcome to Technical Session 7E. Myself, Prashi, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastics, LLP, it is my great pleasure to welcome you to the 9th International Conference on Smart Trends in Computing and Communications, SMARTCOM 2025, Pune, India. The ninth edition of this conference is being organized in a hybrid mode. The physical event was held yesterday in Pune, India, and the virtual meet is being held through Zoom today and tomorrow, which is 30th and 31st of January 2025. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 10 presentations. Each presenter will be given 8 minutes for the presentations and 2 minutes for the question and answer. Please note that on the 7th minute, I will be raising a gentle reminder. There is another request to all the participants that you will all stay with us till the closing remarks. If you have any query or update, then you can write it to us in the chat box. Just before we start the session, I would like to introduce you all to our session chair for this session, Dr. Kaushal Shah. Dr. Kaushal Shah is currently serving as an assistant professor in the Department of Computer Science and Engineering at Pandit Deen Dayal Energy University, PDU. He has a vast teaching experience of around 11 years. He's an active researcher in the field of information, security, blockchain technology, cryptography, and smart grid. He has also published several paper research articles at reputed venues and delivered keynote talks. We welcome you to this session, sir. Would you like to say anything before we start with our presentation, sir?
No, let's just get started. All the best to all the participants. Stick to the timeline that has been mentioned, right? We can start.
Thank you so much, sir. Now, I would like to start with the papers. I will just call upon our first presenter for this session, Amani A. Aladini, presenting the paper on the title, A Comparative Education of ML, DL and Transformer Models in Arabic Sentiment Analysis. If you are ready with your presentation, I request you to kindly begin with your presentation, please.
Yes, ma'am, I'm ready. Is my hair? Can I start?
Please, ma'am, please.
Okay. Hello?
Yes, ma'am, your presentation is visible and you're audible, ma'am.
Yes, can I start? Okay. Good afternoon, everyone, respected sir and ma'am. In the 9th International Conference SmartCom 2025, my topic is a comparative evaluation of machine learning, deep learning, and transformer model in Arabic sentiment analysis. My content, I will start for introduction. As we see nowadays, sentiment analysis as well as opinion mining is separate so fast. Sentiment analysis is nothing. It is only extract the people opinion or emotion of an even product or others. Sentiment analysis can differ from one language to another. Most research are focusing in English language and little focusing in Arabic language. Arabic, it is around 4.8% of internet user on www World Wide Web. The Arabic language includes 28 alphabet within 25 constant and 3 vowel. Arabic language is a very cursive language and all cursive letters are connected with each other. There are 3 types of Arabic language. The first one, it is classical Arabic. This is the old language, or as we said, of the Islamic language for Holy Quran, Hadith, and Arabic literature. Second language, it is modern standard Arabic language, MSc. It is the formal language for education now. And the last type of Arabic language, it is dialect Arabic language. It is informal, it is depend on the society. Each society what is can accent or use it for this language. Analysis of Arabic language is so much complex with English compared to other language like English language and so on. The main challenges of sentiment analysis for Arabic language, and Arabic language is a complex to analyze because of its characteristics. As we know, Arabic, it is start from right to left. Also, some words have same letter but different pronunciation. Also, we can derive from the root word many different words. Also, there is lack of data set in Arabic sentiment analysis. Also, lack of resources lexicon. There is no till now standard lexicon for Arabic language. Also, recognition, it is very hard as different for English language. You can recognition the names start from capital letter, but in Arabic it is different. It is derived from the adjective. We can say this is the name. Also, this use of Arabis. Arabis, it is Arabic language, but it is used Latinian word to write. It is combined between numbers and Latinian alphabet. But the pronunciation, it is in Arabic language. This is most of research of related work who start with lexicon-based machine learning, deep learning, and transformer. I will start with my methodology. I do data collection, my work. I use 4 different data set. The first step of my methodology. This data set with different size, different domain, so I can compare. First one is hard data set, holy data set, AGGT data set, Arabic tweet also data set for sentiment analysis. Second, it is data processing, how to clean the data to can enter for extraction to the module. Data processing, I clean the data from the noise, remove the URL, return the number here. I can use many functions to clean the data. I remove also the motion, replace it with the text like this love. What is the meaning in Arabic? It is hub. I get here one example. If I can time, I can explain, or I will only go fast. Also normalization, stop word removal, duplication remove, numerical. I use numerical education, stemming, return the main word to the main word. And second, it is feature extraction. It is here convert the text to the number to can enter to my module. I use 3 different module: machine learning, deep learning, and transformer. In machine learning, I use 2 logarithm. Here, this table, it is summarized the 4 different data set with the module. I use random forest and support vector machine to all the different. I find here support vector machine give me the highest accuracy for all the data set. In second, this table in deep learning, I use 2 also data, 2 approaches, BLSTM and BIDRU. Deep learning, I compare, it is the accuracy, it is nearest. No one is better than. All work very nice. And the last thing, it is transformer. In transformer, I use XLM report base and Arabic BERT version 2, also the BERT. When I compare with the accuracy, I get the highest accuracy in Arabic BERT in dataset, hard dataset, it is 94%. It is the best accuracy to all the modules what I use. So I find that transformer module, it is get the highest accuracy. And here is the configuration matrix for the data set, hard data set. What is the accuracy, precision, record, and F1 score, different measure. And this is my conclusion review. Thank you. I hope I try to only summarize in short time. Hello?
Thank you so much, ma'am.
Thank you.
Sir, do we have any questions for ma'am?
Yeah, I just have one question. Can you go to that conclusion slide?
Yes, sir.
Yeah. Uh, So I couldn't get the reason why this particular model that you are saying is outperforming the rest of the model. Can you, I mean, have you thought why is it so?
Uh, the highest accuracy I get for transformer Arabic BERT is give me better than traditional machine learning like support vector machine and also deep learning. All work very nice, but the highest accuracy it is in Arabic BERT
I agree, but why? Why is it so?
because
What is it that they are doing differently?
different maybe because it is probably the characteristics of Arabic. It is some libraries of Arabic. How can analysis, how can clean the data properly, move no noise, yes, the data enter to the module in very nice way.
Okay, okay. We can go to the next presentation.
Okay, okay, sir. Uh, Thank you for presenting, ma'am. You can stop sharing the
Okay,
screen.
yes, thank you, ma'am.
Thank you. Now we'll call up the second presenter, Ms. Eshita De, presenting on the paper titled A Comparative Study of Rainfall Prediction on Indian Regions Using Gradient Boosting and Random Forest Algorithms. If you're available, I do request you to kindly take over the presentation, please.
Ma'am, am I audible?
Yes, ma'am, you're audible. I'll stop presenting so that you can start with your presentation.
Okay, ma'am. And 1 second. Is my screen visible?
Your screen is visible, ma'am.
Good afternoon, respected dignitaries, fellow researchers, and esteemed audience. I am Ishita De, final year BTech student from the Department of Artificial Intelligence and Machine Learning at Techno International Newtown. It is an honor to present at the 9th International Conference on Smart Trends for Computing and Communication. I am here to present the research work titled A Comparative Study of Rainfall Prediction on Indian Regions Using Gradient Boosting and Random Forest Algorithm. This work is a collaborative effort by Ritika Upadhyay, Ishita De, which is me, Monman Patra, and Rosie Khatun under the humble guidance of our mentors Dr. Chinmay Kar and Dr. Somnath Chatterjee. Let me provide you the flow of the presentation. First, we will have a brief introduction on the topic, research gap and objective. Then we will discuss our progress through the proposed methodology and results. In the end, we will conclude our presentation with conclusion and acknowledgement. Now, first come first, let me put a fascinating fact in front of all. That is 45.76% of Indian population is employed in agriculture sector and 60% of cultivated land that depends on monsoon gets affected by unpredictable weather. This is not me claiming the figures, but the Public Labor Force Survey of 2023 and Economic Survey of 2024 who were able to find this out. From this, we can say that rainfall is a crucial resource for the vast democracy of India. Next, moving on to the literature review slide. There, there are already a lot of research work going regarding this, some of which we have put in this research literature review slide, where the paper title Intensity Forecast of Tropical Cyclones over North Indian Ocean using Multilayer Perceptron Model Scale and Performance Verification. According to this study, a MLP model was developed to forecast the intensity of tropical cyclones that prevail over Arabian Sea and Bay of Bengal. The forecast error for some severe cyclones with these models observed to be considerably less. Next, the paper titled Comparative Study of Machine Learning Algorithms for Rainfall Prediction, a case study in Nepal. They have claimed that random forest outperform decision tree and support vector machine algorithms for the rainfall prediction on the dataset collected from various weather stations of Nepal. And next, the paper title An Enhanced Multiple Linear Regression Model for Seasonal Rainfall Prediction have proposed an advanced automated framework called Enhanced Multiple Linear Regression Model with MapReduce algorithm and Hadoop file system. However, the rainfall prediction nowadays has become very challenging due to the drastic change in climate. So for this, the existing rainfall models have become expensive both in terms of cost and computation. By keeping this in mind, we have framed our objective as an effective solution for the rainfall prediction using 150 years of historical rainfall data combined with machine learning algorithms. This research aims to improve rainfall prediction through algorithms such as gradient boosting and random forest and evaluate the models on the basis of mean square error and root mean square error scores. This is our methodology. We have taken 8 essential steps to execute a project. First, problem definition. As discussed earlier, in this step, we have identified the problem and defined the objective. The second step was data collection, where we have collected the longest instrumental rainfall series of Indian regions from 1813 to 2006 from the official website of mm, Indian Institute of Tropical Meteorology, which consisted of total 8 datasets that are North Mountainous India, Northwest India, North Central India, Northeast India, West Peninsular India, East Peninsular India, South Peninsular India, and at last whole India. Next, these datasets were large and each one had a few rows containing null values which were randomly distributed. So we removed these rows in the data cleaning processing phase, which is the third step. The fourth step was exploratory data analysis, where we plotted the correlation matrix of the feature to understand the collinearity between the features. Now these datasets have individual columns for monthly rainfall measurement and seasonal rainfall measurement. The next step was feature engineering, where we decided to train the models individually on two sets of independent features subsequently, first on monthly rainfall measurement and then on seasonal rainfall measurements. Our sixth step was model selection, where for selecting models for our comparative study, we conducted comprehensive literature review and decided gradient forest and random forest regressor for our research work. In the seventh step, that is model training phase, where to get a comprehensive understanding of the rainfall pattern followed over these years, we implemented this step by using two substeps. In the first substep, we took monthly rainfall measurement over the region against annual rainfall measurement and trained the machine learning algorithms like a random forest regressor and gradient boosting regressor on the data. The performance of both the models is observed here. In the second substep, we took the seasonal rainfall as independent variable and annual rainfall as the target variable. Again, random forest regressor and gradient boosting regressor are trained according to the data into consideration and performance of each of the models were recorded. In the final step, that is model evaluation, we compared the accuracy of the models based on MSE and RMSE scores, that is root mean square error and mean square error, and computation complexity of the models as based on training and precision prediction times. This is the flowchart for the random forest algorithm and as same as gradient boosting algorithm. The following four slide depicts the observation of the seasonal and monthly MSE and RMSE observation in the form of tables and bar charts. From the observation, it is clear that gradient boosting regressor performed better in terms of accuracy. Now let's discuss the computation complexity, where we can see the average time required by gradient boosting for training and prediction is comparatively less than the random forest.
Excuse me, Ms. Day. We have completed
Yes,
the
ma'am.
criteria of 7 minutes. I request you to kindly conclude the presentation as soon as possible.
Okay, ma'am. This is the last slide only. In conclusion, we can say that the gradient boosting algorithm performed comparatively better than random forest algorithm both in terms of accuracy and computational complexity. Our future scope is that to extend further by employing time series models on the recent rainfall data. These are the references from which we have taken the resources. And at last, I want to thank you all the audience for patiently listening and mm, giving me this opportunity to present up my presentation. Thank you.
So, do we have
Thank
any
you, ma'am.
questions for ma'am?
Yeah. Anybody from the audience wants to ask anything? They can also ask. If not, then I'll be asking. Okay. So you somewhere mentioned that you are performing data cleaning.
Yes, sir.
So how are you cleaning the data? I mean, you haven't mentioned any detailed technique that can be used for data cleaning.
So actually, we have manually deleted the rows which were containing null values
Okay.
because for yes, sir.
How many rows are there in your data set?
Sir, there are many rows, but only few rows that were containing null value. For
No, no,
only
but then
4-5 rows were there null
then
value.
you would have, I mean, what is the size of the data set?
So it is 150 rows.
Okay, then it's not a very big data set. Then it's fine. Otherwise, when your data set is of size in GBs, manually cleaning it is not a good idea, right? There are many techniques available for data cleaning that can be utilized. Okay,
Okay.
so that's the suggestion from my side. We can shift to the next presentation.
Thank you, sir.
Thank you for the presentation. We'll go for the next presenter. Our next presenter is Vigneshwaran D, presenting on the title AFR System Optimizing Traffic Signals for Emergency Vehicle Prioritization. If you're available over here, I request you to kindly take over the screen and share your presentation, please.
Sure, ma'am.
Yes, sir.
Am I audible? Hello?
Yes, sir, you're audible and your screen is visible as well.
Hello, gentlemen. I'm Vigneshwaran of final year Electronics and Communication Engineering from Prince Sri Venkateswara Padmavati Engineering College, Chennai. I feel great in presenting my innovative idea in this 9th International Conference on Smart Trends for Computing and Communication. Imagine an ambulance with an heart patient urging on the way to get to hospital, get stuck in a red signal in an intersection, unable to move through heavy traffic, uh, while every second counts in saving a life. So, this is a scenario that we witness very often in our cities, where emergency response times were severely impacted by the inefficient traffic management. So, now think, what if we could revolutionize this scenario? What if those inefficient traffic signals could dynamically adjust in real time, giving first responders the fastest possible route? That's exactly what our innovation is. So, the problem is clear. Emergency vehicles such as ambulances, fire trucks, and police cars face delays at intersections due to static and pre-programmed traffic lights. So these delays not only compromise the response times, also can, in critical cases, can cost lives. So there is a pressing need for the real-time and adaptive as well as a cost-effective solution that can prioritize the emergency vehicles to navigate through the traffic without disrupting the overall traffic flow. So our answer to this problem statement is the AFR, which is assistance for first responders, which can integrate to the existing traffic systems without compromising its overall function. So the AFR kit utilizes LoRa communication for a long range as well as low power data transfer between the emergency vehicles and the intersection controllers. So here, when an authorized emergency vehicle approaches the intersection, the system dynamically switches the traffic signals in its favor, allowing an uninterrupted pathway to the emergency vehicle and helps the emergency vehicle navigating through the intersection. This is done through a centralized authorization process, ensuring only the legitimate emergency vehicles could pass through and activate this system, thus preventing the violations as well as the misuse. Once the vehicle passes and crosses the intersection, the traffic lights can get automatically reverted to the normal functioning, so ensuring a minimal disruption to the everyday commuters. So this is of the flow in which the emergency vehicle will be equipped with a LoRa transmitter and the intersections are mounted with a LoRa receiver. So when the communication between these two modules be enacted, the detection of the emergency vehicle be performed and be interfaced to the microcontroller, which will be changing the traffic signals in response to the arrival of emergency vehicle, thus prioritizing the emergency vehicle in this scenario. In impact wise, socially, it actually reduces the emergency response times of the emergency vehicles, also being a greater part in ensuring saving lives. Economically, the fuels that are wasted during the vehicle idling can be reduced and can be promoted for an sustainable environment. So the target audience for for this idea are the private hospitals and the smart city commuters, smart city enablers. So this is what our prototype is, and we have been prototyping it for the past 1 year. So these were the research papers from where we have collected our surveys as well as our motivation being there. So our future focus is on integrating generative AI for a predictive analysis on the system, which could dynamically ensure the adaptiveness of the system. So this is our patent application form. So in conclusion, in our fast-paced lives where every second matters in an emergency, we cannot afford to a outdated traffic system stand in the way of saving one's life. So our AFR kit can upgrade this scenario, which can transform the existing traffic system to a more efficient one. So we invite researchers, city planners, as well as industry leaders to collaborate with us in bringing this innovation to reality. Together, we can ensure that no emergency vehicle is ever stuck in a traffic again. Thank you.
Sir, would you like to ask any questions?
Anybody from the audience? If you want to ask, if you want if you want to suggest something, you are allowed to. Okay, so a nice problem that you have, tried to solve. But I just have one query. Am I audible?
Yes.
Vigneshwar? Yeah.
Yeah.
So what you are saying is you'll be changing the entire existing architecture of traffic signals, right? That would be required.
Possibly
you
to
want.
adjust, like it will be enhancing the system when the emergency vehicle gets navigated and crosses the intersection, the system will automatically revert to the normal functioning.
Okay, but then how would you identify emergency vehicle? Will there be?
Through the LoRa communications.
But then that can be, hacked, right, or intercepted. In terms of security, I doubt, right? If you rely only on signal, it can create some false positives as well, right? So that is where I had a doubt. But if you are, just enhancing the existing architecture, it is good. If you are planning to replace it totally, I don't think that's a good idea. Okay. So that's it from my side. We can go to the next presentation.
We'll possibly look into it. Thank you, sir.
Yeah, yeah.
Thank you for your remarks, sir, and thank you for presenting, Mr. D. Now we'll go for the next presenter. Our next presenter is Varun MV, presenting on the title Analysis of the Audio in the Game of Cricket Using Machine Learning. If you are available with us right now, I request you to kindly start with your presentation, please. Mr. Varun MV.
I'm there. I'm giving the share option. Is my screen visible?
Yes, sir, your screen is visible, sir.
So, good afternoon, everybody. Respected session chair and all the presenters over here. A warm good afternoon to everybody. Myself, Varun MV. I am presenting the paper titled Analysis of Audio in the Game of Cricket Using Machine Learning. I myself, Varun MV, and my co-authors are Venkat Raghavendra H, V. Hemath, and Ashwini Bhatt, and we are representing Department of ECE, BS University. Coming to the abstract of the project, the idea of the project was to classify the ball interaction with the bat and the wicket in the audio spectrum. So we have used random forest and XGBoost for the same. As I earlier mentioned, the objective was to classify the ball and bat interaction. When the ball interacts with the bat, it might be a short sound or a head sound, and when the ball interacts with the wicket, it will be a bolt sound. So we wanted to classify that in the audio spectrum. So we created a data set of 100 samples each in each of the category. So we use techniques of feature extraction and machine learning. So the methodology goes like this. First, we collected the data and pre-processed it, and we extracted the feature from the pre-processed signals. Then we implemented the models in Python. So in the related work, we can see there were a lot of research going on in the image classification through CNN and NN. There was less research paper based on audio classification. However, there was one paper where they have used NN and SVM for the sneak detection using audio in the frequency domain. So the novelty of the project lies in classifying those shorts and edge audios in the audio spectrum. So coming to the implementation part, first we created a data set and we extracted the features from those. So in the pre-processing part, what we did is we considered an .mp4 format, which is a video of the cricketing event, and we converted it to a .mp3 file of the same. Then we trimmed down the audio to the specific length where we have the exact instance of the audio taking place. Then we reduce the noise using the noise reduce library. Then using the Python library librosa, we extracted all the features MFCC, chroma, and spectrogram. So in the dataset creation, there were two subcategories. One is with noise, another one is without noise. So in those two subcategories, there are another subcategory called as mean value feature in the top three coefficient. So in this mean value feature, what we considered is we considered the mean value of all the values of the deviation and consider the mean value for the same, because of which reduce the dimensionality and gives the overall feature idea of the same. In the top three coefficients, we considered only the top three contributing features for the same. The train test ratio was 80% and 20% for testing. So in order to achieve a better accuracy result in the model, we plotted a graph of accuracy versus max depth and accuracy versus number of estimator in order to achieve a good accuracy for the same. And these are all the results for the same with noise and without noise for XGBoost and random forest. The performance metrics which we consider is accuracy, precision, recall, and F1. Coming to the results, random forest model with noise and with mean data performs the best, which gives us the 90% accuracy, whereas the top three coefficients doesn't improve the outcomes of the results. While testing the model for the same, we use Google Colab as the environment, and for each of the classification, it takes 3 seconds per audio input. While testing, we came to there was a margin of error in the model. So while testing the three samples, two of the samples were classified as correct as edge and short, while one was misclassified, which is the bold audio was misclassified as short, in telling us that there's a margin of error in the model and it keeps to be improving. So coming to the conclusion of the project, so we have classified the audio of the ball and bat interactions, and the future improvements would be increasing the data set, would be increase the accuracy and accuracy of the predicting the ball and bot interaction, and different models can be tried out. These are the references. Thank you.
So, do you have any questions?
Yeah. So you might have heard the term sneakometer. Have you heard?
Yes, sir.
So will your solution be better than Sneeko? Is there any evaluation of performance or comparison between the two?
No, sir. We didn't consider stigmometer references, but we consider the what we recorded in the a game of the cricket. While the broadcasters were showing us the video, we collected this data set and we classified the results, not the stigmometer results.
So what is your end goal? What is it that you want to achieve through this?
We wanted to classify the short. Sorry.
You can continue. I guess it is by mistake somebody else.
Okay. So the objective was to classify the different types of ball and bat interactions along with the wicket for the audio purposes by using ML. That was the goal which we need to achieve.
I mean, still I'm not being able to. What is the real life application? That's what I'm saying. Whether the batsman has touched the ball or not, right? That is what
Yes,
is
sir.
something that. So
Whether
then
the
it.
batsman has hit the ball for the boundaries, or it has been edged and caught behind, or whether the
Okay.
batsman is being bowled. That is the audio classification which we tried doing.
Okay. So Sneeko is, I mean, doing nicely. And then, do you think yours would be required?
It can be helpful in the future aspect.
Okay.
Sneakometer is
Okay.
doing good, but with the help of ML, there will be a much more accuracy in the results, which we believe in while doing the projects.
Okay. Okay. Thank you. We can go to the next presenter.
Sure,
Thank you,
sir.
sir, for your feedback.
Thank you for presenting. So, I request you to kindly stop sharing. Okay. We'll take on to the next presenter. The next presenter is N. Janani, presenting on the topic cross-modality attention networks for multi-phase lung tumor detection. If you are available with us, I request you to kindly start with the presentation, please. Ma'am N. Janani. Looks like ma'am is not available with us. We'll take on to the next presenter, sir. Our next presenter is Parekh Ritika Dhawal, presenting on the paper titled Enhancing Visual Question Answering for Medical Images Using Transformers and Convolutional Autoendorer. I request you to kindly take on to the presentation if you're available with us. Ms. Rekha, Ms. Dhawal, are you present along with us? We'll go to the next presenter. Our next presenter is Rituraj Pradhan, presenting on the paper title FFAFER, Fiducial Focus Augmentation for Facial Expression Recognition. If you're available with us, I request you to kindly take over with your presentation, please.
Yes, hi, am I audible?
Yes, sir, you're audible. I'll just stop sharing. I request you to kindly take over with your presentation.
Okay.
Thank you.
Is my screen visible?
Yes, sir, your screen is visible.
Okay. 1 second. Yes, good afternoon, everyone. My name is Rituraj Pradhan. representing the Department of Mathematics and Computer Science from the Sri Sathya Sai Institute of Higher Learning. I'm here to present my paper titled Fiducial Focus Augmentation for Facial Expression Recognition. To get started, the agenda for this presentation is the motivation behind the work, the application of the work, related work, the key contributions of this work, the methodology behind it, the experimental setup we have used, the results and discussion, limitations and future work, and the final conclusion. To get started the problem domain that we are working with here is facial expression recognition, in which essentially what we do is we take static images of faces as exemplified in these images right here. And these images are classified into one of 7 or 8 expression classes, such as happy, sad, angry, surprised, disgusted, fear, neutral, and other. Now, the primary challenges that we face in FER is data scarcity and for labeled datasets, overfitting on small datasets, and the need for augmentation techniques tailored to FER. Because you see, when you look at a face and you try to classify its expression, that classification is subjective. Different people can read different faces differently. And furthermore, it is true that in computer vision, there are a lot of augmentation techniques available, but there is nothing particularly tailored towards facial expression recognition. So along those lines, the objective for this work was to bridge these FER challenges using a novel landmark-based augmentation approach. So the applications of this work will be towards healthcare, where we can monitor health better by understanding what the face is expressing. For customer services, it enhances interpretation of user emotions, and for technology development, because it improves the resilience of FER systems to occlusions and real-world challenges. In terms of related work, the primary inspiration or the primary motivation for this paper, for our work, was this proposal made by Punarbayan et al. At Sony Research, titled Fiducial Focus Augmentation for Facial Landmark Detection. What this paper proposes is, as an augmentation technique, they take the ground truth facial landmark coordinates and introduce black N×N patches on the face as an augmentation. And they start with large, let's say 5x5 or 7x7 pixel patches on their images, and slowly reduce the size of these patches as training progresses. And they propose that the same augmentation technique could work for facial expression recognition too. In our work, we try out their proposal and we find out that the opposite is true. So the key contributions of this paper is that we've adapted a curriculum-based landmark augmentation to address unique posed challenges in facial expression recognition. We've developed FFA-FER, which is a robust framework that leverages pre-trained insight face models for accurate landmark detection and progressive augmentation. And we have validated this model's effectiveness through extensive experiments on RAFDB and FER plus datasets, demonstrating improved resilience and interpretability in FER systems. Now, the methodology itself, what we do is we take our input image and we pass it to a pre-trained landmark detector, insight face in particular for this paper. And this will give us 106 landmark coordinates. We take these coordinates and we introduce black patches at these coordinates gradually. So for the first 8 to 10 epochs of our training, we train our models without any patches or augmentation, just a basic random flip for basic variation. So we train our model for about 10 epochs without any augmentation so that the model gets familiarized with the data. And as our accuracy or metrics start to stabilize, we start introducing these new patches. We start with 1x1 pixel dots, then go to 2, 3, 4, and 5. We gradually increase the size of these patches every 8 steps in our experimentation. Let's say we are training our model for 50 epochs in total. Then for the first 10 epochs, we train the model without any FFA, FER, or without any patch augmentation. Then after every 8 epochs, we increase the patch size by 1. Then this augmented image is passed to our model. And finally, we do a softmax to get our emotion label. The experimental setup, so the data set we've used, RAFDB, which has a total of 7 basic emotion classes, and it has 12,000 plus images. FER Plus, it has 8 emotion classes, it has improved annotations, and a total of 28,000 images. The models we have experimented with is ResNet 18, which is a lightweight CNN, SwinFace, which is a VIT or a transformer-based architecture, and we have Mobile FaceNet, which is optimized for efficiency. The results themselves, we start with a base experimentation with only random flip, where we horizontally flip the image at random for 50% of the time. And then we tried with the method proposed by Punarbayan et al. In the Sony proposal, which is decreasing patch sizes, and then with our proposal FFA-FER of increasing patch sizes. And we can see that across all experiments, across all three models with the RAFDB, we are seeing improvements of at least 1% in F1 score. Furthermore, in FER plus also we see similar outputs with marked improvement in all models. Now, these are the breadcrumb visualizations of our work. So with the base model that was trained on random flip on RAFDB, you can see that the attention of the model is a bit spread apart. It's focusing on more, it's not focusing on the overall structure of the face. And that is what we are trying to introduce using FFA-FER. As the attention maps show you that when we introduce this brand new augmentation, the model does not the model basically learns to focus on the overall structure of the face. And that's how it's able to improve performance. The limitations of this work, per se, is hyperparameter sensitivity, as I mentioned in the methodology, that it is sensitive to the size of the patches. How often are we increasing the size of the patches? How long do we train the model on unaugmented data? And also the focus currently is only on static facial expression recognition. So in the future, what we can do is we can automate the tuning of these hyperparameters with reinforcement learning, and we can extend this augmentation to dynamic facial expression recognition with videos and multimodal systems also. In conclusion, FFA-FER introduces a novel augmentation strategy leveraging facial landmarks to enhance FER performance, and the curriculum-based approach progressively improves model focus on expression-relevant features. And it demonstrates improved accuracy and interpretability on RAFDB and FER plus datasets, and it holds the potential for diverse real-world applications, including healthcare and adaptive interfaces. It is a promising foundation for future advancements in dynamic FER and multimodal emotion recognition. Thank you. That was my presentation. Thank you for your patient listening. If you have any questions, I'll be taking them now.
So do we have any questions for him?
Yeah. So how are you claiming your proposed system to be novel?
Given the fact that there is no work out that proposes leveraging facial landmarks, pre-trained facial landmark detection models to support or enhance the performance of facial expression recognition problem space. And that way we are the...
Because yeah. So as far as what I have explored, there are few schemes available for this as well, right? So you may go through it one more time. There are few proposals which are also considering what you have mentioned about landmarks, right? So they might have used a different word for the same, but whatever I have heard you explaining, I could relate it with what they have proposed as well, right? So that would give you a kind of a comparative analysis sort of a stuff, right? So yours can still be novel, but then you'll get somebody with which you can compare your results, right?
Yes. Okay.
So yeah, that's one suggestion from my side. We can go to the next presenter.
Thank you so much, sir. We'll go for the next presenter. Our next presenter is Kashish Arora, presenting on the title Hybrid Model of Chaos Theory and Quantum Techniques for Portfolio Optimization. We request you to kindly take over the presentation if you're available with us.
Good evening, everyone. My name is Kashish, and I, along with my co-author, Dipali, I'm delighted to present our research on hybrid model of chaos theory and quantum techniques for portfolio optimization at SMARTCOM 2025. Our study aims to enhance financial making by integrating chaos theory, sentimental analysis, and the quantum approximation algorithm to optimize stock portfolios. And let's begin. And these will be the agendas that we'll be talking on. Introduction. The stock price prediction is a complex challenge due to multiple influencing factors such as market trends, investor sentiments, global economic events, and inherent chaos in the price movements. Traditional models such as LSTM and time series forecasting primarily rely on historical data to fail to incorporate real-time influences like public sentiment and nonlinear price movements. It leverages sentiment analysis to assess how public opinions influences the stock prices and uses chaos theory to analyze unpredictable price fluctuations. It also applies QAOA, that is quantum approximation optimization algorithm, to efficiently optimize asset selection by balancing risk and returns. This is the hybrid approach that we are offering. Our research builds upon various prior works that explore financial forecasting techniques. Some key references are here.
So let us now discuss about the data and methods. So we have taken this data set from Kaggle. Sentimental analysis was already performed. So we have the tweet on which analysis was performed, the name of the company mentioned in that tweet, the last price recorded before the date, then the first day return, second day return, and so on. Then we have the PX volume, which shows the total amount of stocks sold on that day. Volatility helps us to represent the fluctuations in stock price. Then LSTM polarity is the sentiment that was recorded in the tweet. Here 1 represents positive sentiment and -1 represents the negative sentiment. After sentimental analysis, we have received the updated data set. We have applied chaos theory, which helps to find the sensitive regions in the stock and find the assets or companies which have less chaotic behavior. On these assets, we further apply quantum approximation optimization algorithm that helps us to find optimal assets and form the optimized portfolios. The major methods that we have applied are chaos theory and QAOA. So chaos theory is basically used for unpredictable systems, which are large random systems with underlying hidden patterns. Chaos theory helps us to understand those patterns, and its butterfly effect is known for how even the small changes in initial conditions results in the vast different outcomes. So chaos theory helps us to understand stock dynamics and how it is functioning. QAOA, on the other hand, is a combinatorial algorithm that helps us to find the various combinations of optimized assets while maximizing returns and minimizing risks. So in our research, we have evaluated 15 companies simultaneously. This helps in enhancing portfolio performance and reliability.
Traditional models ignore chaotic market dynamics, leading to inaccurate predictions. Our approach learns from chaotic behaviors and leverages quantum optimization, ensuring faster and more precise decision making. The core innovation of our research is the integration of chaos theory, sentimental analysis, and the QAOA. Chaos theory implementation utilizes the Lorentz system model to nonlinear stock price behaviors, which reveals the chaotic attractors allowing us to identify stocks with a high sensitivity to market conditions. The fractals and sensitivity analysis examines fractals and sensitivity matrices to identify investment opportunities. Random forest classifier trained to classify the stocks based on chaos indicators and sentiment scores helps detect market patterns and filter stocks for optimization. Quantum approximation algorithm constructs quantum circuits to optimize asset selection, evaluates 15 company assets, and selects optimal low risk and high return stocks using quantum superposition. Here is the proposed methodology of our research. Firstly, the stock price has been taken and the sentimental data has been processed, and the data pre-processing has been occurred, which is the complete data set that has been taken by us from the Kaggle. And the chaotic analysis that we have applied on our data set, firstly, we have initialized a Lorentz system and then generated the trajectories, which also generates the Lorentz attractor plot. And then it also leverages the machine learning techniques, which focuses on feature scaling random forest classifier, model evaluation, and feature evaluations. Then a quantum optimization has been performed, which firstly initializes the qubits and define quantum circuits, optimize parameters, and measured results. And then the chaotic features are extracted, and life within our exponents is calculated, which also represents the sensitivity analysis. And on the chaotic analysis, quantum has been applied, which maps the quantum results, generate recommendation, and calculate the portfolio matrices and invest decision charts.
Now let's see the experimental results. So after applying sentimental analysis, we have applied chaos theory to identify the sensitive regions and predict the chaotic behavior in stock market. So for chaos theory, we have received the accuracy of 95.71%. This is the graph that we received. In this, we have the data for 15 companies arranged in sorted descending order. Three metrics, namely precision, recall, and F1 score, were used. And these points show us the regions below which the predictions can be made with 95.71% accuracy. So on the chaos theory results, we have applied QAOA, which has provided the optimized parameters beta and gamma. Beta represents the stock sensitivity, which has value 1.15, and gamma represents market sensitivity, which has value 1.41. These are the optimized portfolios that we have received. As you can see, we have different combinations for the same 15 companies in which we can invest. So in conclusion, our paper utilizes a hybrid approach, combining the features of sentimental analysis, chaos theory, and quantum techniques like QAOA, and finds the optimal portfolios by balancing risk and return. Chaos theory helps us to identify the high sensitive regions in the stock and study market behaviors. QAOA helps to select the top performing companies and receive various optimized portfolios. Future work may include advanced quantum neural networks to improve accuracy and market adaptability. These are some of the references. Thank you. If you have any questions, we will be happy to answer them.
So would you like to ask them any questions?
ठीक है बाद में देख लेंगे क्या करना है मुझे तो बोल क्वेश्चन आ जाएंगे so what is it that is you are getting as a accuracy right now
For the chaos, we
you
have got the
mentioned
accuracy
some you mentioned something in future work that by bringing that quantum learning you can still improve, right? Neural network of quantum can still improve, but what is it that you are getting currently as in terms of percentage? What is the accuracy?
So for chaos,
Result
we
section
have received the accuracy of 95.71%. And after applying QA, we have got the value of beta and gamma, which are the parameters which help to optimize.
This accuracy is based on the market and stock sensitivity, not on the percentages. So here it is.
Okay. Okay. So I mean, in a way, you are optimizing the risk score, right?
Yes, sir.
Okay. Okay, that's it from my side. How many papers we are left with?
So we are left with 2 papers by now.
Okay.
Thank you, everyone.
Okay, so yeah, so I might be taking a small break. I'll be coming back, but you can continue the presentation, right? Do you need anything from my side at the end? Anything that you require? Because I have a urgent meeting where I received the call just now. So it wasn't planned, but I'll have to go and attend it. It might take around half an hour, 45 minutes. So
Sure, sir, we'll continue without you. Last, we'll just have the your certification to show and a snapshot to be taken. That's it.
okay.
So if you could join us, that would be good. If not, we'll adjust, sir. We understand.
Okay. Okay. So just drop a message to me the moment the presentations are over. I'll, through my phone, I'll try to join so that ceremony which is you are saying can be done. Okay.
Sure, sir. Thank
Yeah.
you.
Thank you.
Now we'll go on to the next presenter. Our next presenter is Vaidehi Deshpande, presenting on the topic Learning Beyond Limits, exploring augmented reality and virtual reality in education and training. If you are here with us, I request you to kindly take away the presentation.
Hello, am I audible?
Yes, you're audible.
Okay, so just a second.
Okay.
Can you see my screen?
We can see the screen.
Okay, so good afternoon, everyone. I am Vidan Deshpande, and today I'm going to be presenting on behalf of Vaidehi. So I am a final year student in Electronics and Telecommunication Engineering at Pune Vidyarthigriha's College of Engineering and Technology. And today I'm here to talk about our review paper, that is Learning Beyond Limits, Exploring Augmented and Virtual Reality in Education and Training. So is my screen still visible?
Yes, your screen is visible.
Oh, yeah. Okay, sure. So let me start by introducing the topic of our paper. So as I think everyone in this meeting can agree that we live in a digital world where new technologies are evolving and coming out in every day, every second. And two of the most important technologies that we deem important to the field of education and training are augmented reality and virtual reality. So let me start by explaining what do these terms exactly mean. Augmented reality refers to the process in which digital or virtual content is overlaid on top of the real world, whereas virtual reality is the process in which an entirely new virtual world is created, and we can enter that world. So these technologies can be used to enhance learning and make it much more interactive. So we have identified that it can be especially useful in education, where it can help visualize complex and abstract concepts and make it much easier for students to engage with subjects such as physics, biology, history, geography, etc. And in the field of professional training, AR and VR technologies can be used to provide safe and cost-effective skill development, especially in hazardous fields like the military. Okay, so the theoretical foundation of a paper is built on 5 theories, them being the constructivist learning theory, which states that AR and VR technologies can enable learners to actively know can actively learn and have immersive and interactive experiences. Then the experiential learning theory states that AR and VR technologies can allow learners to learn by doing. That is, they can experience the simulated environments and perform hands-on practicals at home without the use of any machinery. The dual coding theory states that AR and VR technologies can help learning by combining visual and auditory information, making it much more easier for students to retain the information. And we also have the situated learning theory and the cognitive load theory, which state that AR/VR technologies can break down the cognitive load of the learning by making information much more digestible and visually aesthetic. So, as we have discussed, AR and VR technologies are ready to revolutionize the existing domains by implementing state-of-art technologies and enabling remote learning by overcoming geographical and logistical barriers. So, let me explain to you some of the papers that we have gone through. So, okay, so the first 2 papers are about AR/VR technologies in education. So School AR, an educational platform to improve students' learning through virtual reality. In this paper, the authors created a virtual reality platform that allowed students to visualize concepts visualize concepts like cellular systems in biology, terrains and plates in geography, and historical tours of historical places in history. So the findings were a 30% increase in retention rates, a 25% improvement in comprehensive scores, and an 80% satisfaction increase. The digital game-based technology for English language learning also use the same technique where a augmented reality-based game was created and used to teach the students about topics such as vocabulary, grammar, and pronunciation. The result, 45% increase in vocabulary acquisition and a 30% improvement in pronunciation accuracy. And in the professional training field, we have a virtual reality table and a HoloLens-based AR system that allows biology students to study anatomy training without using a real cadaver. A 75% 20 to 30% better task performance was seen. Then the virtual reality and haptic CPR training system taught students how to perform CPR using VR haptic feedback systems and motion tracking sensors with a 30 to 40% improvement. Then then authors also used wearable feel through haptic devices that could that manipulated just how someone perceives softness. This also allows you to this also allows a increased softness trigger. And finally, an AR VR technology assisted fire drill training. This utilized both AR and VR along with sensors for fire drill training and allowed a 40% higher response time. So, about the advantages of AR and VR, augmented reality allows users to explore abstract concepts in 3D, making complex ideas much more intuitive while also controlling the difficulty, pace, and content based on the learner's progress. AR VR also provides immediate access to diverse scenarios, reduces the need for expensive physical equipment, and enables remote learning. And an interesting use of AR VR in the field of healthcare is its use to as an exposure therapy to treat phobias and PTSD. However, AR VR technologies also come with a disadvantage, as most of the high-end VR devices like the Microsoft HoloLens and the HTC Vive are very expensive and most people cannot afford them. Also, prolonged use of AR VR can lead to health problems such as eye strain, headaches, and also can cause detachment from real world relationships and responsibilities, along with addictions. AR, VR, and mobile applications. So the development of specialized mobile applications for AR, VR technologies is crucial for making learning accessible to everyone. As post-COVID, mobile applications have become much more significant in education. The future directions. So the AR and VR education training market is growing rapidly with a projected compound annual growth rate of almost 55% in the next 5 years. The scalability and affordability of the technologies has increased. We have also started using cloud and edge computing to enable the delivery of content remotely, hence no need of data centers.
Just to
And
interrupt, sir, you have exceeded the criteria of 7 minutes. I do request you to kindly conclude as soon as possible.
okay, yeah, sure. Just a second. So let me just explain about the research gaps. So the main research gaps in the field of AR VR today are we don't exactly know how exactly can it affect long-term retention and skill development in students. That is one thing that we have to find out. And AR VR also needs to be much more personalized and adapted. So every student who uses the app or uses the technology can learn equally as fast as others. And also the ethical concerns which have to be addressed as well. So concluding that AR and VR are not a replacement for traditional learning, but a powerful addition. You cannot expect a student to learn everything just based on technology itself, nor just by rote learning and memorizing formulas. We would suggest that to have the optimal blend of both these technologies, we should AR and VR technology should only be implemented in learning secondary school onwards. Hence, we are going to be using this to make our final year project. Thank you.
Thank you so much, sir. Now we'll be taking up our last presenter of the session. Para Upender, presenting on the title Quality Assessments of Fruits and Vegetables Using Deep Learning. So if you're present over here, I request you to kindly take
Yes,
over.
madam. Yes, madam. 1 minute.
Yes, sir.
Is my screen visible, ma'am?
Yes, sir, your screen is
Yes.
visible.
Yes, good afternoon, one and all. Myself, I'm Para Upender, working as an assistant professor in Keshav Memorial Institute of Technology. My paper ID is 750 and title is Quality Assessment of Fruits and Vegetables Using Deep Learning Techniques. So the objective of my paper is training deep learning networks and transferring knowledge for the systems so that automatically we can assess the quality and classification systems over the fruits and vegetables. That is what the major agenda. And here you can go with the traditional ML and transfer learning. In the traditional ML, knowledge is not retained or accumulated. And learning will happen with respect to considering the past learning knowledge. Whereas in transferring learning, we can use the advanced concepts like ResNets, where the knowledge can be transferred. So that processing will be faster, more accurate, and training time will be less. Here you can see the difference between isolated single task learning and transfer learning. And the models which are used in transfer learning are three. One is VGG, and another one Inception V3, and residual networks. Among residual networks, we are having two models. One is ResNet 18 and ResNet 50. Here 18 and 15 are the number of layers. Here you can see the architecture design of my proposed model, where the input is given as images of the fruits and vegetables as a data set, where pre-processing and feature extractions will be done and cross-validations will be done and given to ResNet 18, where again it will be divided into input blocks and classification blocks and output blocks. From that, the classification will be done for two categories. One is fresh, another one is rotten. So if an image is given after processing, it is going to give as an output whether it is fresh fruit or rotten fruit. Here in the ResNet 18, the internal architecture can be shown here. This is the ResNet 18 architecture where it will have 18 layers. In that 16 convolutional layers are there, and one average pool layer is there, and one max pool layer is there. Where in the average pool layer, we will use batch normalization, and in the max pool layer, we will use ReLU activation function, which contributes to powerful future extraction in order to determine the quality of whether it is a fresh fruit or a rotten fruit. And in the computational, the mathematical calculations will be done and generates 1.8 into 10 to the power of 9 floating point operations. And here, the architecture design of that ResNet 18 are 18 layers. The first two you can see, and in the middle we are having 4 into 3, 4 into 3, 12 plus 2, 14 plus here in the down you can see two more layers, 16, and then max pool layer and average pool layer and max pool layer. So totally 18 layers are included in the ResNet 18, where it can process input blocks and determine classification blocks and output blocks. From there, the classification will be done of two categories. One is fresh fruits, another one is rotten fruits. Training and optimization, where the training was carried out by over 10 epochs were taken in this paper with one optimization technique, that is adaptive moment estimation, using which will work with CNN models, deep CNN models, and other neural network models to improve speed and performance of gradient-based optimization, particularly for large data sets and complex models. And for loss calculation, we have taken alpha value, where we have taken 0.7 value, which can vary from 0 to 7. For experimental sake, this alpha value also can be changed. The selection of fruits and vegetables here. We have taken 3 types of fruits and 6 types of vegetable images. Over 30,350 images we have taken, fruits and vegetable images we have taken. And for the training sake, we have taken 23,000 plus. And for testing images, we have taken 6,000 plus images to train the model. The fruit size estimation. The paper still who have worked on this kind of research, the people have worked only determining rotten or fresh fruits only, but they haven't concentrated on fruit size estimation, where we are focusing on fruit size calculation. For that sake, 3 steps we follow. One is contour detection, where we will find the boundaries of the image of whether it is a fruit or it may be a vegetable, and bounding box where the determined image of the fruit or vegetable, the boundaries will be drawn, and next size calculation will be done. The width and height of the particular bounding box will be determined. And image acquisition and pre-processing. First augmentation is done, and then after that data balancing is done. In the data balancing, we are taken only 1500 images. If it is less than 1500, we leave the data set as it is. If it is above 1500 images, the extra images were taken considering as a new data frame, and then labeling over the fruits and labels. Performance metric, where accuracy can be calculated based on true positive and true negative, and true positive plus true negative plus false positive plus false negative. Here, the number of correct predictions divided by total number of predictions are taken into consideration to determine the accuracy, or that precision, recall, and F-score values also calculated. And existing systems are here, the people we used to basic CNN, VGG, and Inception, where the accuracy rate is 86% and 95, 94 only, and loss value is very high. And in the proposed system, here you can see we are able to improve that accuracy rate up to 98% over the 10 epochs for the both fruits and vegetables identification and their freshness classification. Comparing with other techniques, here 98% of accuracy is observed, and loss value is very less. Here is a confusion matrix where you can see in the proposed model, the true positive and true negative values are 959 and 926. Based on this only, accuracy will be determined. So by observing this, we conclude that the accuracy is improved to 98%. The final conclusion, the proposed model achieved the training accuracy of 100% and testing accuracy of 98%. And we use here ResNet 18, where computational power is less, memory is less, and very faster. Next, over the other, compared to other papers, in the proposed paper of our paper, it concentrate on size of the fruit as a feature, which is not which is not in which is not there in previous papers. And we use here ResNet 18, which can be integrated with YOLO, which can work with the real world deployment, where multiple images can be given as an input to determine the output. And future research directions are as multiple in present present research paper, we included input image as only one. In future, we can include multiple images, and we can extend it to more number of fruits and more number of vegetables, and we can deploy it to in real-time applications. This is what the future research directions. And these are the reference papers. Thank you.
Thank you so much, sir, for presenting. Now we'll be closing the session.
Thank you, ma'am.
Thank you so much, sir. I sincerely thank our authors and for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during this 9th version and all the other previous 8 versions of this conference. We will be happy to have you for the 10th version in 2026. All the presenters will be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of SMARTCOM 2025. I will also like to thank our session chair for chairing our session today.
Madam, a small queries that can we ask?
Sure, sir.
Can we change the order of the authors in the paper?
Sir, I request you to kind. I'll just conclude the session. I also like to thank our session chair. A token of appreciation to the chair on behalf of Team SmartCom 2025 and Global Knowledge Research Foundation and partners. Thank you so much for your valuable presence, sir. Would you like to end with any remarks from your end? for this session?
Yeah, I just wanted to say one or two things. I mean, it was very well managed. First thing is that, because usually the timings which are given, it is very difficult to start on time, right? So I'm very happy that we started on time. And second thing is, I congratulate all the authors. They have also managed the timing, which I expected from them. So it was in that way, it was very pinpoint presentation that everyone has presented. And congratulations, your work would be published very shortly, and all the best. That's it.
Thank you, sir. I kindly request all of you all to please open your cameras for a quick snapshot of this virtual session. All the presenters present over here, I request you all to kindly please switch on to your cameras so that we can have a snapshot of this session. Thank you so much. Now we'll end the session and see you on the next session in 2026. You all can log yourself out. Stay safe and take care. Thank you so much.
Okay. Thank you. You may send the
Thank
screenshot
you.
to me as well. I'll keep it as a memory. Yeah.
Okay.
Thank you, ma'am. Thank you,
you.
sir.